You know, in the digital world, there's a system, and it's breathing. Its lifeblood, data. Its currency, computation. But what happens when that system gets pushed to its breaking point, not by accident, but by design? Today we are going deep into the shadows of AI security to look at a vulnerability called unbounded consumption. It's a threat that works in total silence right up until it's way too late.
So, the attack, it starts quietly. You don't get an alarm. No security alert pops up. There's just a number on a screen, and it's climbing. First it's pennies, then dollars, then thousands. It's like a silent hemorrhage, just draining your financial resources, eating up processing power with this invisible, insatiable appetite. Every single tick of the clock is another cycle burned, another dollar just gone.
And for everyone else, the actual users, the developers, the business that relies on this thing, the result is the same. The screen just goes blank. The connection times out. The system, which was once buzzing with activity, is now a total ghost town. The service is just unavailable.
Now, this chaos, it has a name. Unbounded consumption. That's the ghost in the machine we just saw in action. See, large language models are uniquely vulnerable here because their resource use is directly tied to how complex the inputs are. Every single token, every query, it costs real computing power, real money. And when an app fails to put a cap on that consumption, the consequences aren't just technical glitches. We're talking catastrophic failures, denial of service, financial ruin, and yeah, even the outright theft of the AI's core logic.
So how does an attacker actually pull this off? How do they lay siege to a system like this? Well, it's not just one single trick. It's a calculated, multi-pronged assault on the model's resources and really its very identity.
Let's open up the playbook, shall we? These aren't just lines of code we're talking about, they're strategies. Each one is designed to exploit the very nature of how these large language models actually work and how they're deployed in the real world.
Okay, the first play is all about brute force. It's called the flood. An attacker just bombards the model with a relentless stream of inputs, all of them different sizes. Think of it like a digital tsunami, designed specifically to overwhelm the system's ability to process anything, to choke its memory and just grind everything to a complete halt.
Then you've got something a little more insidious, the drain. This one, it targets the wallet. By kicking off a massive storm of high-volume operations, attackers exploit the pay-per-use cloud models that, let's be honest, most of these AIs run on. They're not trying to crash the system here. They're trying to bankrupt it. It's what we call a denial of wallet attack, and it turns the service's own business model into a weapon against itself.
And then, maybe the most sophisticated play of all, the clone. The goal here isn't destruction, it's theft. Attackers actually use the model's own intelligence against it. They feed it these carefully crafted inputs to generate enough data to train a whole new model, a functional replica. This is an intellectual property heist on a massive, massive scale.
And don't make the mistake of thinking this is just theoretical. This threat is very, very real. The blueprint for this kind of heist is alarmingly simple. An attacker just queries the target model's API over and over again. They take those outputs and use them to create a huge synthetic dataset. Then, they take all that data and use it to fine-tune a completely different foundation model. And the end result? A functional equivalent. A shadow model built from the stolen mind of the original.
So, with a playbook that powerful, how in the world do you fight back? Well, you don't just patch a hole, you have to build a fortress. The whole narrative has to shift now, from threat to defense, from chaos to control.
And the difference really comes down to chaos versus control. A vulnerable system is basically a digital free-for-all. No quotas, no one watching the gates. But a fortified system, that's a structure built on rules. Things like rate limiting to control the flow of traffic, user quotas to stop any one person from draining all the resources, and anomaly detection to spot an attack before it really blows up. Defense has to be a layered strategy. There's no single silver bullet here. We're talking about an entire toolkit. Strict input validation is your first line of defense, rejecting malicious requests right at the door. Resource management throttles any greedy processes. Sandboxing basically isolates the model in a digital containment field, cutting off escape routes and stopping wider damage. And then you have tools like watermarking and monitoring that give you the intelligence to see who is using your model and how.
So let's map this out so it's crystal clear. For every threat, there's a primary countermove. If you're facing a denial of wallet attack, your go-to defense is rate limiting and setting user quotas. Trying to stop someone from cloning your model? Watermarking your outputs and using logic masking, which basically hides the model's internal next word probabilities, are absolutely key.
It's a strategic game of chess, right? Every move the attacker makes has a specific, powerful counter from the defender.
But here's the thing. Technology alone is never the complete answer. Now, this isn't a problem you just solve one time and walk away. It's a perpetual standoff, an ongoing battle of wits that always comes back to one critical, unpredictable element: the human in the loop.
Yeah, the source material itself makes this crucial point. As this quote highlights, the perimeter isn't just external. The vulnerability of unbounded consumption is so significant because it also covers threats from the inside. Think about it: a disgruntled employee, a compromised account. The most dangerous attacks can come from people who already have the keys. Vigilance is and always will be a human responsibility.
Which leaves us with this one final lingering thought. We are in a constant race, building smarter and smarter systems, while attackers are devising more intelligent ways to break them. So as AI continues its exponential leap forward, the real question is this: are our defenses evolving fast enough to keep up?